Hi, boys and girls. It's Miss Millerick, and I have a very scary story to tell you. Just kidding. But today is going to be our last day that we talk all about light energy. So let's quickly go over some of the things that we've already mastered up until now before I teach you a few new things. I can explain what light is. Well, boys and girls, what is light? We know that light helps us see, right? I turned the light on, and that's the only reason why you could see me. Can you see me now? Nope, because light energy allows us to see. I can observe that light travels in a straight line. We know that light travels directly in a straight line. I can explore how materials affect light. Let's look at 3 different ways. And the 3 types of materials that we've been exploring so far have been transparent materials, right? Like this plastic yogurt cup. We also have been exploring translucent materials, like this piece of tissue paper. Kind of goes through it, right? And lastly, opaque materials. The light cannot go through the book. Just stops right there. I can name sources of light. My first grade friends, this is something else that you can do with light energy. You know that the sun is light energy. A flashlight is light energy. A light bulb is light energy. Lastly, I can describe different kinds of light. Let's go over some of the pictures that you guys looked at last week. So here's a beautiful photograph. The light source is the sun, I would assume. It is behind the sunflower, right? And it's the largest source of natural light. It's the largest source of light. And it's lighting up everything behind the sunflower. You could see that the sunflower is blocking it. And also, if you look over to the left-hand side of the photograph, it looks like there's little speckles of light too. So the light is dispersing. So this is an interesting picture. And at first, Ms. Millerick had a really hard time describing this one, right? I would say that the red and the blue and the yellow and the green lines look like laser beams. That's one way I would describe this picture. You could also say that the light is dispersing into a rainbow. It's hard to tell where this light is coming from, but it is probably unnatural, I would say, that it's an unnatural light source. And then lastly, we have this beautiful photograph. It looks like it was taken from the beach. It actually looks very familiar. It looks like it could have been taken from Winthrop. But some ways that you can describe this picture and the light in this picture, you could say that it's natural light. The reason why the beach is lit up is because the sun is still out. It is sunset, and that's why the light is starting to look orangey and pink. Something else that we haven't really talked about yet is that the light is being reflected off of the water. You could see the light reflecting off of the water. And then lastly, light is also being absorbed in this photograph. If you see the clouds here, it looks like the sunlight is going through the clouds. So that means that light is being absorbed through the clouds. The clouds are translucent, and that is how we are still able to see the sun's light. Lots of ways to describe this picture. How did you guys describe the lighting in this picture? So, that little activity was designed to teach you guys and to help you learn that not all light is the same. Some light can be dim, like the room that I'm in right now. It's not really bright, it's dim. Some light can be super bright, like this flashlight light, right? That's very, very bright. Some light can be fluorescent, some can be neon, like that side picture of the person with those bright colors. Not all light is the same, but all light helps us see. So I have this really fun investigation set up, and I will give you all of the details in case you want to do it at home. But this investigation is going to teach us another way that light and light waves can behave, just like sound. It has all these different components. All right, so this science lab is called Pencils and Water. And the materials that we need are a clear cup. I have a glass cup, but you could use a plastic cup too. Water and a pencil. That's all you need are those three things. So it says, what will happen when we put the pencil in water? Well, first, I'm just gonna fill the cup up, not the whole way, about 2/3 of the way with water. And then I need to make a prediction. What do I think is going to happen to the pencil when it goes inside of that cup of water? Well, I don't really think anything special is gonna happen. I know that light travels in a straight line, so I'm gonna draw my prediction of, the pencil just sitting inside of the cup. So I'm just going to draw my prediction, and you might have the same exact prediction, but don't copy Miss Millerick just because this is mine. I want you to think of your own, right? And I'm just doing a quick pick. You would use more details than I did. And then the pencil. And I'm also going to label my drawing, of course. Cup, water, pencil. Then it says, I predict the pencil will. I don't really think anything is going to happen, so I predict the pencil will sit there. That's what I'm going to write. It's just going to sit there. Or sit there. I'm going to change this up actually. Sit there in a straight line. Period. It says put the pencil in the water, what happens? So let's test it out now. So I changed the cup. I got a taller, narrower glass because I feel like it will help us make better observations and you can really see what happens here. But I have the same pencil. So what I'm gonna do, place it on in. Ooh, what happens there? Do you guys see what I see? I'll get closer. Did that pencil break? Did the top of it shift over? Do you see right where the water cuts the pencil? Uh-oh, let me take the pencil out. Oh wait, nothing has happened to the pencil. It's the water. Water is a material, it's matter, it's a liquid. So the light that's filling up this room is reacting with the water and the pencil. And what it's doing is it is refracting. That is what happens when light bends. It refracts and it just looks like the top of the pencil has shifted. Pretty cool. I wonder if the same thing happens with a straw. I'm gonna take out the pencil and put a straw in. Yep, same thing happens. You could see even more with the straw. Look, it's a straight straw. It can be bendy, but it's straight right now. Pretty cool. That's what light refraction looks like. So what did I observe? I observed, I'm gonna draw my observation. Remember, I'm just doing a quick pick. I know you guys are going to put more effort into your observation drawing. But what happens is the pencil went straight up to the water And then it looks like it snapped and shifted to the side, right? Pencil, water, glass, and I'm going to write my conclusion. I conclude that light waves can refract. And I want you to write your own sentence down here. If you decide to do this activity or any light activity that you end up doing after this video, I want you to make sure that you're writing your own conclusion sentence about what you learned down there. What I want to do now is show you guys this very quick Bill Nye the Science Guy video on light bending and bouncing.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
This magnifying glass is making my eye look big. Now, why is that?
I don't know.
Please consider the following. When light enters something like air, water, glass, or plastic, it slows down a little. And when it slows down, it changes direction. See how one eye is lower than the other? See? Take a look at this. Here are 3 straight beams of light. When they go into the piece of plastic straight, they come out straight. But if the plastic is tilted, the beams of light get tilted. See, they change direction so that they come out this side offset. Now, what would happen if the piece of plastic didn't have straight sides, but had a curved side, like a magnifying glass? Well, the light would change direction, right? Because the surface of the plastic is curved, each beam of light enters the piece of plastic at a slightly different angle, and it changes direction a slightly different amount. Look, over here, the beams of light come together at a single point. This is called the focal point. Now, what about the magnifying glass? Well, suppose your eye were over here, and light from the room were bouncing off of your eye and going through the piece of plastic this way. Well, then the small area at this end would be spread out over a large area on this side. Your eye would be magnified. Thanks for joining me on Consider the Following.
Bill Nye the Science Guy.
I can explain light refraction. So now we can add this to our master of skills. The pencil bending in the water was light refraction. And you absolutely, positively know what that is. That's a rainbow, not only one rainbow, there's 2. It's a double rainbow. How do rainbows happen? You might remember, because sometimes we would see them in Miss Millerick's room. But do you remember how it happens? Well, go over to that follow-up activity and you will find out. You're going to do an investigation and make your own rainbow. I hope you have fun, first graders. Great job learning all about light energy.